Welcome to our data analysis course. Today we're diving into the basics of NumPy, a fundamental Python library that's essential for anyone working with data. Whether you're just starting out or looking to sharpen your skills, understanding NumPy will give you a huge advantage. In this video, we'll explore why NumPy is so important, how it works, and see some practical examples to get you started. Let's unlock the power of faster, more efficient calculations together as we begin our journey into the world of data analysis. NumPy stands for Numerical Python. It's a powerful library designed to handle numerical computations efficiently. Unlike regular Python lists, NumPy works with arrays, which are more compact and allow for faster operations. This makes it a go-to tool for anyone dealing with large datasets or complex calculations. In the world of data analysis and machine learning, NumPy is often the backbone that supports more advanced libraries and workflows. Let's see why it's so widely used. Why is NumPy so important? First, it's much faster than using standard Python lists, especially when you're working with large amounts of data. NumPy arrays are optimized for performance, allowing you to process and analyze information quickly. This speed is crucial in data science, where efficiency can make a big difference. Plus, NumPy supports vectorized operations, which means you can perform calculations on entire arrays at once, rather than looping through elements one by one. NumPy isn't just about speed, it's also about making your code cleaner and easier to read. In data science, you'll often need to perform calculations on large datasets, and NumPy's array-based approach makes this straightforward. Many other popular libraries like Pandas and SciPy are built on top of NumPy, making it a foundational skill for anyone in the field. Mastering NumPy opens the door to more advanced data analysis techniques. Let's compare NumPy arrays to regular Python lists. While lists are flexible and easy to use, they're not optimized for numerical operations. NumPy arrays, on the other hand, are specifically designed for mathematical calculations. They use less memory and allow you to perform operations much more quickly. This difference becomes especially noticeable when you're working with large datasets or need to perform complex calculations repeatedly. Getting started with NumPy is simple. To create an array, you first need to import the library using import NumPy as NP. Then you can create an array by passing a list of numbers to NP array. For example, NP array 10, 20, 30 creates an array with 3 elements. This array can now be used for fast and efficient calculations, making your data analysis tasks much easier. One of the most common operations in data analysis is calculating the mean or average of a dataset. With NumPy, this is incredibly straightforward. Simply use the mean method on your array. For example, if you have an array called r, you can find its mean by writing rmean. This saves you from writing loops or extra code, making your workflow much more efficient. Another frequent task is finding the sum of all elements in an array. NumPy makes this easy with the sum method. Just like with the mean, you can call rsum to get the total of all values in your array. This is especially useful when working with large datasets where manual calculations would be time-consuming and error-prone. Shape of an array tells you its dimensions, such as how many rows and columns it has. In NumPy, you can check the shape of an array using the shape attribute. This is especially important when working with multidimensional data like matrices or tables. Knowing the shape helps you organize and manipulate your data more effectively, ensuring your calculations are accurate. One of NumPy's biggest advantages is its support for vectorized operations. This means you can perform mathematical operations on entire arrays at once, rather than looping through each element. For example, you can add, subtract, multiply, or divide arrays directly. This not only makes your code cleaner but also significantly speeds up your calculations, which is crucial for data analysis. NumPy is designed to handle large numerical datasets efficiently. Its arrays are stored in contiguous memory blocks, which allows for faster access and manipulation. This is a major benefit when working with big data, as it ensures your calculations remain fast and reliable even as your datasets grow in size. NumPy isn't just useful on its own. It's also the foundation for other powerful data analysis libraries like Pandas. Pandas builds on NumPy's array structure to provide even more advanced data manipulation tools. By mastering NumPy, you're setting yourself up for success with Pandas and other libraries that are essential for data science. Machine learning relies heavily on numerical computations, and NumPy is at the heart of many machine learning workflows. Libraries like scikit-learn and TensorFlow use NumPy arrays for data storage and manipulation. Understanding NumPy will help you transition smoothly into machine learning projects, giving you the tools you need to work with complex algorithms and large datasets. To use NumPy in your Python projects, you need to import it first. The standard way is to write import NumPy as NP. This gives you access to all of NumPy's functions and features. Using the alias NP is a common convention that makes your code shorter and easier to read. You can easily create a NumPy array from a Python list by passing the list to NP array. For example, NP array 1, 2, 3 creates an array with 3 elements. This is the first step in converting your data into a format that's optimized for analysis and computation. NumPy arrays can store different types of data, such as integers, floats, or even complex numbers. You can specify the data type when creating an array or let NumPy infer it automatically. This flexibility allows you to work with a wide range of numerical data, making NumPy suitable for many different applications. Just like Python lists, you can access individual elements in a NumPy array using indexing. For example, R0 gives you the first element. You can also use slicing to access a range of elements such as R13, This makes it easy to retrieve and manipulate specific parts of your data. NumPy supports multidimensional arrays, which are useful for representing matrices or tables of data. You can create a 2D array by passing a list of lists to NP array. Multidimensional arrays are essential for many data analysis and machine learning tasks, allowing you to work with more complex data structures. The shape of a NumPy array is a tuple that shows its dimensions. For example, a 2D array with 3 rows and 4 columns has a shape of 3, 4. Understanding the shape is crucial when performing operations that require matching dimensions, such as matrix multiplication or reshaping data. NumPy allows you to change the shape of an array without changing its data. The reshape method lets you reorganize your data into different dimensions. This is particularly useful when preparing data for machine learning models or visualizations where specific shapes are required. Broadcasting is a powerful feature in NumPy that allows you to perform operations on arrays of different shapes. NumPy automatically expands the smaller array to match the shape of the larger one, making calculations more flexible and efficient. This is especially helpful when working with datasets of varying sizes. NumPy makes it easy to perform element-wise operations such as adding, subtracting, multiplying, or dividing arrays. These operations are applied to each element individually, making your code more concise and efficient. This is a key advantage over traditional Python lists, which require loops for similar tasks. NumPy provides a range of aggregation functions such as sum, mean, min, and max. These functions help you quickly summarize your data and extract important insights. For example, rsum gives you the total, while rmax finds the highest value. Aggregation is essential for data analysis, allowing you to make sense of large datasets. Boolean indexing lets you filter arrays based on conditions. For example, you can select all elements greater than a certain value by writing RR10. This powerful feature makes it easy to extract subsets of your data that meet specific criteria, streamlining your analysis. NumPy includes tools for generating random numbers, which are useful for simulations, testing, and creating sample datasets. The NP random module lets you create arrays of random values, making it easy to experiment and test your analysis techniques. NumPy makes it simple to save your arrays to disk and load them later. The NP save and NP load functions let you store your data in binary format, ensuring fast read and write operations. This is especially useful when working with large datasets that you need to process over multiple sessions. NumPy arrays are often used as the basis for data visualizations. Libraries like Matplotlib and Seaborn rely on NumPy for efficient data handling. By preparing your data with NumPy, you can create clear and informative charts, graphs, and plots to communicate your findings. NumPy provides tools for handling errors and exceptions such as division by zero or invalid operations. By using functions like np-seterr, you can control how NumPy responds to different types of errors, ensuring your analysis remains robust and reliable. The official NumPy documentation is a valuable resource for learning more about the library's features and functions. It includes detailed explanations, examples, and tutorials to help you deepen your understanding and solve specific problems as you work with data. NumPy has a large and active community of users and developers. This means you'll find plenty of tutorials, forums, and online resources to help you troubleshoot issues and learn new techniques. Being part of this community can accelerate your learning and keep you up to date with best practices. NumPy is widely used in industry for tasks ranging from financial analysis to scientific research. Its speed and efficiency make it a preferred choice for professionals who need to process and analyze large volumes of data quickly and accurately. NumPy integrates seamlessly with other Python libraries such as Pandas, SciPy, and scikit-learn. This interoperability allows you to build powerful data analysis pipelines, combining the strengths of multiple tools to tackle complex problems. NumPy is optimized for performance using low-level C code under the hood. This means your calculations are executed quickly, even for large datasets. By leveraging NumPy's efficient algorithms, you can handle more data in less time, making your analysis more productive. NumPy arrays use less memory than standard Python lists thanks to their compact storage format. This efficiency is crucial when working with big data, as it allows you to process more information without running into memory limitations. If you're new to NumPy, don't worry. The library is designed to be user-friendly with clear syntax and helpful documentation. Start by experimenting with simple arrays and basic operations and gradually explore more advanced features as you gain confidence. As you become more comfortable with NumPy, you can explore advanced features like broadcasting, masked arrays, and custom data types. These tools allow you to tackle more complex data analysis tasks and optimize your workflows for specific needs. Researchers in fields like physics, biology, and engineering rely on NumPy for numerical simulations and data analysis. Its precision and speed make it ideal for scientific computing, enabling breakthroughs in a wide range of disciplines. When dealing with big data, efficiency is key. NumPy's optimized storage and fast computation capabilities make it a top choice for processing massive datasets. Whether you're analyzing millions of records or running complex simulations, NumPy helps you get results quickly. Now that you've learned the basics of NumPy, you're ready to tackle more advanced topics in data analysis. Continue practicing with real datasets, explore additional NumPy functions, and start integrating NumPy with other libraries like Pandas and Matplotlib. To get the most out of NumPy, follow best practices like using vectorized operations, avoiding unnecessary loops, and keeping your arrays well organized. These habits will help you write efficient, readable code and make your data analysis projects more successful. Let's recap what we've covered. NumPy is a powerful library for numerical calculations, offering fast and efficient operations on arrays. It's essential for data analysis, machine learning, and scientific computing. By mastering NumPy, you're building a strong foundation for more advanced data science tools and techniques. With a solid understanding of NumPy, you're ready to move on to more advanced data analysis topics. Consider learning about Pandas for data manipulation, Matplotlib for visualization, and scikit-learn for machine learning. Each of these builds on the skills you've developed with NumPy. The best way to master NumPy is through daily practice. Try working with different datasets, experimenting with various functions, and challenging yourself with new problems. Over time, you'll become more comfortable and efficient in your data analysis work. NumPy is constantly evolving with new features and improvements being added regularly. Stay updated by following the official documentation, community forums, and online tutorials. Keeping your skills current will help you stay ahead in the fast-paced world of data analysis. Congratulations on completing this introduction to NumPy. You've learned about its key features, how to use arrays, and why it's so important for data analysis. With these skills, you're well on your way to becoming a proficient data analyst. Keep practicing, keep learning, and enjoy your journey into the world of data science.